Hello everyone, welcome to Biot-Savart Law and its applications, the second application on the axis of circular coil. Now, in this figure, we have a circular coil of radius capital R and we have a current element right here which makes a radius R to the point in which we need to find the magnetic field and also from the horizontal distance x from the center. Now, this is the direction of the magnetic field given by the right hand rule. So like this, it goes like this, making a certain angle with the axis. And here we need to find it on the horizontal component because here it is giving off some angle. And let's just write the Biot-Savart law, which is mu naught 4 pi I dl sine theta by r square. Now again here sine theta will be equals to 1 because for in this figure as well the current element is tangential to this circular coil as well, meaning that the angle between dl and this radius is 90 degrees. Because if you have this right here and the radius, no matter where the radius is, this angle right here will always be 90 degrees no matter where it rotates, right? So dB will be equals to mu naught by 4 pi I dl by r square. But we need to find the horizontal component. And here what we do is we introduce another current element that is diametrically opposite to this one. That means right here dl, and we again join this to point P. It will have radius r alpha here and the direction will be given like this, dB dash, let's see. And of course dB dash will again be the same to this, and from these two directions we can find the cos component and also the horizontal components. So here dB cos alpha will act on it and dB dash cos alpha will act on it. Here of course this is also alpha because, well, angle between two lines is equals to the angle between their normals, so this will become alpha, and also you can prove it geometrically. And of course these two will be dB sine alpha and dB dash sine alpha. Now why did you introduce another current element? Well, here in this figure if you see, this dV cos alpha and dB dash cos alpha as well, well, they are equal in magnitude but opposite in direction, acting in same line of action. So that means the cos components or the vertical components cancel each other out. And if we hadn't introduced this dB dash, the another one, then we would have two components, first the vertical and the horizontal. And since we only want it on the axis, we need to eliminate the vertical component. So this is why we introduced another current element diametrically opposite to the first current element. So that means this dB sine alpha, or on the horizontal component, both of them are equal in magnitude and acting in the same direction. That means they don't cancel out, and instead this dB sine alpha is acted on this horizontal component. So that means the total magnetic field would be the integration of dB sine alpha. And here, well, let's first find a definite integral from where it starts and where it goes. So for this we need to look at the current. First it starts out at 0 and then it covers the whole circle, which will be 2 pi r, which is the circumference of this circle. So this will be 0 to 2 pi r. dB is mu naught 4 pi I dl by r square sine alpha. Now let's take the constants outside. Mu naught 4 pi I dl by r square sine alpha, and like in the previous application we will get integration of 2 pi r by dl, which will give just 2 pi capital R. Now sine alpha. We can find the value of sine alpha well using trigonometry, which will be radius perpendicular into hypotenuse, which is mu naught, well pi cancels, 2 cancels, mu naught to r square idl into r by r into r. So it will be mu naught, sorry there is no dl, mu naught I r square by 2r cube. Now typically you can leave it at that, but you can actually go on further, because here this radius, using well again Pythagoras theorem, this radius will be equal to square root of r square plus x square, which we can write in fractional power as r square plus x square whole to the power 1 by 2. So that means that this will be equals to mu naught ir square by 2 r square plus x square by 1/2, but we have cube, so the power just multiply and it becomes this. And again, if there are n number of turns, finally the magnetic field becomes mu naught ni r square by 2 r square plus x square 3 by 2. This may look crazy, but after you have done this derivation number of times, it will look fine, I guess. But still, this part is crazy, this part is simple. And also from here, if you say that well x is equals to 0, meaning that well magnetic field at the center, so basically finding magnetic field at the center if x is 0, then here this will become r square into 3 by 2, the power 2 cancel, becoming r cube, and this r cube and r square here will become r, so meaning we get mu naught ni by 2r, which is the Biot-Savart law, or the magnetic field at the center of circular coil. Hence this is well verified. This equation is true, and if you learn something new, please like and subscribe. Thank you.